In this session we discuss about the operators and expressions. These operators are operands. Operators are symbol that operates operands. Operands are variable constant. So by the help of operator we can connect the variable and the constant, which makes some equation. That equation is called expressions. So operators are symbol that operators operate operands. Operands are variable and constant. For example, x plus 5. X is a variable, pi is a constant, but plus is a operator. The operators are classified based on number of operands. Number of operands means that is number of variable or constants. Unary operator. So unary operators operate only one operand. For example, increment operator, plus plus. Binary operator, it operates two operands. For example, addition, multiplication. Ternary operators operate three operands. That is conditional operator, question mark, colon. In unary operator, plus plus a. That increment operator, that is plus plus a, it operates only one operand. That operand name is a. That is a is a variable. So it operates only one. A plus b. So a is a one operand, b is another operand. So a plus b, plus is a operator. So plus operate two operand. So it is called as binary operator. In ternary operator, it operates three operands. So classification, operators are classified based on number of operator, three types. So another classification based on functionality. The functionality of operator, it classified as follows. That is arithmetic operator, increment decrement operator, modulo division operators, relational operator, logical operator, bitwise operator, assignment operator, conditional operator, comma operator. These are all the operators classification based on functionality. First we discuss about the arithmetic operator. It is a first type of operator based on the functionality. Arithmetic operators are addition, subtraction, multiplication, division, plus, minus, star, slash. These four operations are arithmetic operations. So arithmetic operators have addition, subtraction, multiplication, division. And these arithmetic operators connect operands to make expressions. By using this operator, we can make equations. By using this operator, we connect variable or constant. That is, we connect operands, which will make some expression. Like the expression is called arithmetic expression. Suppose we, by the help of arithmetic operator, we can connect two operands. So it makes some equation. That equation is called, that is the equation. Equation also called as expression. That expression is called arithmetic expression. For example, a plus b slash 2 star d. In this case, a, b, 2, d. These are all operands. Plus, slash, star are arithmetic operators. So this equation is called arithmetic expression because this equation formed by the help of arithmetic operator. So it operates some operands. So this is called as arithmetic expression. The next type is increment or decrement operator. Increment decrement operator based on the number of operates only one operand, because increment decrement operator it operates only one operand. So this is also called as unary operator. Increment operator plus plus is increment operator, minus minus is decrement operator. This one is a free increment. This one is pre-increment operator. Plus plus a is a pre-increment operator. Plus plus is a plus plus a is pre-increment operator. A plus plus is post-increment operator. That is before the variable. It placed before the variable. Suppose if the increment operator, that is double plus, that increment operator placed before the variable, this pre-increment operator. Suppose that increment operator placed on after the variable, it is post-increment. In a similar way, minus minus a, the decrement operator placed before the variable, so it is pre-decrement. The a minus minus, the decrement operator placed after the variable, so it is a post-decrement. In a plus plus or plus plus a, the both are same meaning. That is, it is a equal to a plus 1. A plus plus or plus plus a, both are same meaning. That is, a plus plus is equal to a equal to a plus 1. Plus plus a is also equal to a plus a equal to a plus 1. In similar that, minus minus a or a minus minus, both are similar meaning. Both are equal. That is, it's equal to a equal to a minus 1. If we put minus minus a, it's equal to a equal to a minus 1. If we put a minus minus, it also equal to a equal to a minus 1. For example, integer a equal to 3. B equal to plus plus a. Increment and then assign. Here it is only single operation, that is increment operation only, one operand is there. Here also only one operand is there, a single operation. But in this example, B equal to plus plus a. So here two operation is there. One is increment, another one is assigning. In this case, plus plus a, that is pre-increment operator, first increment and then assign. First increment, the value 1 into a. First increment a value 1 into a, that is plus plus. First is increment, then it is assigned. So first increment, the a value is already 3. Now the a value is 4. Then it is assigned to b. So now b value is also 4. The second example, that is in this line, b equal to a plus plus. It is a post increment. So here also two operations will perform. One is increment, another one is assigning. But it is a post increment. So first assign, then increment. If two operation is applicable in any equation, the post increment is post increase. First assign the first operation. So it is a post increment. First it is assign, then it is increase. Assign means the a value is 3. So first assign, that a value 3 is assigned to b. Now b value is 3. Then a value is increased by 1. So now a value is 4. A plus 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 a are both are equal. Both are equal to a plus 1. But if two operations is performed in the equation, if two operation is there, in this case two operation is there. One is increment, another one is assigning. So it is a pre-increment. First increment, then assign. In this case, two operation is there. One is increment, another one is assigning. But it is a post increment. So first it is assign, then it is increment. Another example, integer b equal to 3. Print of percentage d, that is 4% d is there, plus plus b, b plus plus, minus minus b, b minus minus. Here also two operation. One operation is print the value on the screen. Another operation is increment. Here also print the value increment. Here also print the value decrement. But in the first case, plus plus b, it is a pre-increment operator. First increment, then print. So B value is 3. First increment, then print. The B value is 3, it's add with 1, and now the new value is 4. The 4 print, that is increment, then print. So display 4. In second case, B plus plus, it is a post increment. First print, then increase. Because here B value is 4, because already B value is 3. In this increment, B value is changed as 4. Here B value is 4. It display then increment, because it is here post increment. So display 4, then increment. So increment means that is, it is add one value to B. The old value is 4, add with 1 means 5, the value is 5. But it display only 4, because it display then print. The first print, then increment. In next one is decrement B, minus minus B. B value is 5. So then in the second B plus plus, first print, then increment. So B value is 5. Here this decrease by 1. Now pre-decrement. So the B value decreases by 1 first, then print. So 5 decreased by 1 means 4. So B value is 4, then print. So display 4. And next B minus minus, it is a post decrement. First it print the value of B, then it is decreased. What is the value of B? Here 4, because it changed 5 to 4, then it is print. Here it's print, then decrease. So display 4, then it is decreased to 3. So after the print it is decreased. So the current value of B is 3. So A plus plus or plus plus A, both are same. Both are equal to A plus 1. If it is it stand alone. It stand alone as A plus plus or plus plus A, both are equal. If it perform 2 or 3 operations, in this case 2 operations, that is increment and assignment. Pre-increment, first increment, then assign. Post increment, first assign, then post increment. Here also 2 operations, one print and increment. So pre-increment, post increment, here. So both are equal if it is standalone. If 2 or more operation is performed in a specific expression, so it differ, post increment and pre-increment is differ with one another. Then another type is modulo division operator. So modulo division operator is also called as remainder operator. Percentage symbol is a remainder operator. So that remainder operator it gives remainder value. For example, in this program, main opening the printf percentage 4 modulus 3. That is remainder of 4 modulus 3 is, if divided by 4 by 3, the remainder is 1. 4 modulus minus 3, that remainder is not minus 1, it is plus 1. Minus 4 modulus 3, the remainder is minus 1. Minus 4 modulus minus 3, the remainder value is not plus 1, it is minus 1. Because in division, quotient only consider numerator and denominator sign. In the division, it is a normal mathematics. In division, the quotient value only consider the numerator and denominator sign. But in remainder, in multiplication, the remainder only consider the numerator sign. 4 modulus 3. The numerator sign is plus, so the remainder is 1. 4 modulus minus 3, the numerator sign is positive, so it will display 1. Minus 4 modulus minus 3, the numerator sign is minus, so display minus 1. minus 4 modulus minus 3, it consider only, remainder consider only numerator sign. So minus 1. This example is also 10 modulus 3, the remainder is 1. 10 modulus 3 minus 10 modulus 3, the result is minus 1. That is denominator sign is remainder sign. The quotient sign is it combinedly, there is numerator and denominator, numerator and denominator sign. So the numerator and denominator sign only applicable to quotient. So numerator sign only applicable to remainder. So remainder sign is similar to numerator sign. Then another one type is relational operator. Relational operator, that is less than, greater than, less than or equal to, greater than or equal to, not equal to. These are relational operator. This operator relate two operands or two expressions. So it's called as relational operator. These are all the relational operator. For this example program, integer a equal to 5. Now the a value is 5. Here if a equal to 3, a value is 5, 5 equal to 3, condition false. If it is else, it display blue. But it is not display blue, it display 5 equal to 3, it display blue. 5 equal to 3 mean condition false, false mean blue, but it display red only. If we change a double equal to 3, it display blue. Because if you put only single equal sign, it treat as assignment operator. It is a assignment operator. So compiler, it treat as assignment operator. If we put double equal sign, the compiler treat as relational operator. In this case, a equal to 3. So a value is 5. This is a assignment expression. So the value 3 is assigned to a. If existing values overwritten. A value is 5. After this expression, the a value and the 3 is replaced by, the 5 is replaced by 3. The new value of a is 3 only. But in C language, non-zero values are true, zero value is only false. So a equal to 3, the value 3 is assigned to a, the 3 is treated as true, so it display red. If we put it double equal, the value is 5 is equal to 3, it relate. If we put double equal, it relate, otherwise it assign. If it is a non-zero value, it is true. If it is a zero value only, it is false. If we change a double equal to 3, the result is blue. If we put only single equal, the result is red. The next example, integer a equal to 7, b equal to a greater than 3. A value is 7, so 7 greater than 3, the condition is true. The value 1 is assigned to b. If the condition is false, the value 0 is assigned to b. Because a is a 7, 7 greater than 3, the condition is true, so 1 is assigned to b. So now b value is 1. If a plus b greater than c plus d, so relational operator is applicable to for arithmetic expression also. So relational operator related to operand or expression. So in this case we use two expressions. A plus b is a one arithmetic expression. C plus d is a one arithmetic expression. So we put greater than. So the total expression called as relational expression. So first add value a plus b, then add c plus d. The value of a plus b, the value of c plus d, it compare the two values. If the summation of a plus b is greater than summation of c plus d, the condition is true. Suppose a plus b summation value is less than summation of c plus d, the condition is false. So next type is logical operator. A logical operator is and, or, not. Totally three kind of operators. One is and, or, not. Double ampersand symbol. So this is the operator symbol for and, logical and. Two pipeline symbol. This is the logical or. This symbol for to represent the logical or. So exclamatory symbol to represent the logical not. If expression 1, expression 2. Expression 1 means it may be operand or expression. It may be anything. So the expression 1, expression 2. If we put logical and, that is expression 1 and expression 2. We put logical or, expression 1 or expression 2. The expression 1 is false. Expression 2 is false. Expression 1 and true. Or expression 1 and expression 2 are both are false. The result is false. Expression 1 0, that is false. Expression 2 non-zero, that is true. In C language, non-zero or true, 0 or false. It is false and true. The result is false in logical and. Expression 1 is non-zero. Expression 2 is 0. Non-zero means true. True, false also false. Non-zero, non-zero. Both are true. Expression 1 is true and expression 2 is also true. So both are true. Expression 1 and expression 2 are true. The both conditions are true. The result is true. This is logical AND. In logical OR, expression 1 is false, expression 2 is false, the result is false. The expression 1 is false, but the expression 2 is true, the result is true. In OR gate, either 1 is true or both are true. Logical OR, result yield true. Result will yield true. For 0, 0, 0, 0 true, that is 0, 1. Non-zero means that is true. Expression values, that is total result is true. But logical AND is true only the expression 1, the expression 2, both are true. The logical AND the result is true. In logical OR, in expression 1 or expression 2, either one is true, the result is true. If both are true, in logical are also true. For example, A greater than B. If the A value is 10, B value is 20, so 10 greater than 20, the condition is false. Here we put not operator, so it convert as true. If A value A greater than B is true, the not operator gives a negation to that. That is, A greater than B is true. After not operator, it is false. A greater than B is false. After the not operator, it is true. S1 greater than 50 and S2 greater than 50. If S1 is greater than 50, the condition is true. S2 greater than 50 condition is true. Both are true. Only the if condition is true. In this case, either one is true. S1 may be greater than 50 or S2 may be greater than 50. Anyone or both are true, the condition is true. Another one is bitwise operator. Now, bitwise operator operate operands by bits rather than bytes. In previous type of operators, and these in previous operators are operate bytes, but bitwise operator operates bits. So that's why it called as bitwise operator. These operators can operate integer and character, but not other data types. This operator can operate only integer and character. Bitwise operator does not applicable to other data types except integer and character. Bit manipulation operators help to write system software. Bitwise operator very helpful to write system software. That is translator, operating system, device driver. So it's suitable to write system software. These are all the bitwise operator. This one is a ones complement operator. Double greater than symbol called as right shift operator. The two less than symbol is called a left shift operator. One ampersand symbol is bitwise AND. If we put two ampersand symbol, it is logical AND. It operates bytes. If we put only single ampersand symbol, it is called bitwise AND. It operates bit by bit. This is if one single pipeline operator called as bitwise OR. If we put two pipeline symbol, it called as logical OR. The single pipeline is bitwise OR. The caret symbol is bitwise XOR. For example, expression 1, expression 2. The first expression is false. False means 0, true means 1. So 0 represents the false, 1 represents the true. But expression 1, expression 2, expression 1 and expression 2. So expression is 0, expression 2 is 0. So expression 1 bit is 0, expression 2 bit is 0, the result is 0. So any one is 1, the result is 0. Both are true, the result is true. Just like our logical AND, but logical AND operate byte-wise, it operates bit-wise. This is also just like our logical OR. Any one is true, true. Both are true, true. But both are false only, it is false. XOR. In XOR operator, any one expression is true, only true. Both are 0, it is 0. Both are true, it is 0. So any one is 0. Expression 1 or expression 2 is 0. Any one is 1, that is expression 1 or expression 2. Any one is 1, in XOR operator, the result is 1. Otherwise it is 0. Both are 0, the result is 0. Both are 1, the result is 0. In this program, integer a equal to 3, b equal to 7, c, d, e, f, g, h. So these are the variable. A variable hold 3, b variable hold 7. So d, e, f, g, h, these are the variable. C equal to 1's complement of a. That is a tilt symbol is a 1's complement operator. 1's complement means that is what is the value of a? A value is 3. So a is an integer variable. So the size is 2 byte. 2 byte means 16 bit. So it is a positive value. So the first bit is sign bit. In 16 bit, the first bit is a sign bit. If the first bit is 0, it is positive value. The first bit is 1, it is a negative value. But 3 is a positive value. The first bit is 0. The equivalent binary of 3 is 1 1. Here because totally 16 bit. Integer a is an integer variable. The size is 2 byte. So 2 byte means that is 16 bit. So here just you see that these are all the 16 bits. All are 0. The last it is a 1 1. There is a equivalent of 3. Equivalent binary value of 3. This is equivalent binary because so bits is a function. In this program, so bits is a function. So it shows the binary form of the value. Binary form of value. So bits of a mean a value is 3. It shows binary form, but it is an integer. So it shows 16 bit. Display 16 bit. So all are 0. The last 2 is 1 1. It is equal to 3. The binary form of 3. The next so bits b. B is 7. Equivalent to that is binary form of 7. Binary form of 7 is 1 1 1. In C equal to 1's complement of A. 1's complement. So A consists of 0 0 0 0 1 1. So if we take 1's complement for that value, zeros change to 1, 1 are changed to 0. 0 change to 1, 1 is changed to 0. That is opposite. So this is a value. 1 is changed to 0. Next one is changed to 0. Remaining zeros are changed to 1 1 1 1. This is the 1's complement. D equal to B right shift A. The B binary form of B is, that is B value is 7. The binary form of 7 is this one. right shift 2. So this is a binary form of B. Right shift means in right side 2 bits are shifted. 2 bits shifted. The 2 bits are in right side. You truncate 2 bits. Then add 2 0 in left side. So totally 16 bit. So it is a right shift 2 means right side 2 bits truncated. And left side 2 zeros added. So this is the value. The triple one. Right side double one is truncate. Then double zero added with left side. So double zero is 1. This is a right shift operator. In similar way, B left shift 3. B values. This is the B value. Left shift 3 means it truncate 3 bits from left. Add 3 0 on right. It truncate in left shift operator in B binary form. The binary form of B is 0 0 0 1 1. So left shift 3 it truncate 3 bits on left side. It add 3 zeros on right side. This is the value of E. After the left shift of 3 bit, the value of E is this one. Then FE equal to A bitwise B. The binary value of A is 11. Binary value of B is 111. Based on this table, if we, that is the expression 1 and expression 2 are both are true, only true. So in this case 1 1 the value is 1. 1 1 the value is 1. 0 1 is 0, another 0 0 0 are 0. So this is the value of the binary form of F. This one is a binary form of F. In G equal to A bitwise R B. The value of the binary form of A, the value of A is 3, the equivalent binary form of 3 is this one. And the value of B is 7, the equivalent binary form of 7 is this value. In this case, A or B, just we refer this table. Both are true, in bitwise R, both are 1, it is 1. Any one is 1, it is 1. Both are 0, only 0. In this case 1 1, both are 1, the value is 1. Both are 1, the value is 1. But any one value is 1, 0 1, it also give 1. 0 0 0 0 0 0. This is the value of G. Now the next expression, H equal to A XOR B. The binary form of A is this value. The binary form of B is this value. In XOR, both are 0, the result is 0. Both are 0 or both are high, the result is 0. Any one is 1, the result is 1. So 1 1, both are high, the result is 0. 1 1, both are true, the result is 0. 0 1, any one is 1, the result is 1. So both are 0, remaining are 0 0 0. This is the bitwise operator, operations of bitwise operator. Another one type is conditional operator. Conditional operator, so question mark colon is a conditional operator. This is ternary, this is also called as ternary operator because this operator operates 3 operand. So it called as ternary operator. In this case, expression 1, question mark, expression 2, colon, expression 3. That question mark colon is a conditional operator. If the expression 1 is true, the expression 1 is true, the expression 2 is executed. The expression 1 is false, the expression 3 is executed. For example, Z equal to A greater than B, question mark A colon B. A greater than B. If the condition is true, the value of A is assigned to Z. If the A greater than B is false, the value of B is assigned to Z. Because after the question mark is true expression. After the colon, is a false expression. If the expression 1 is true, the after the question mark execute. If the expression 1 is false, after the colon is execute. So in this case, a greater than b question mark, that is nested conditional operator. We can also write like this, that is a greater than b question mark. If the condition a greater than b is true, this expression is executed. That is a greater than b is greater than c question mark a colon or c. The a greater than b is false, the after the colon equation is executed. If the a greater than b is true, it compare with a c. The a value is greater than b, then the a value is compare with c. If the condition is true, the value of a is highest, so it assign the a value is assigned to z. If the a greater than c is false, the c value is assigned to z. If a greater than b is false, so the b value is compared with c. If the b value is true, the b value is high, the b is assigned to z. The b value is low, the c is assigned to z. So after that expression, the z value has highest value of 3 variable, highest value of 3 variable. We can also write like this, that is print of percentage d, a greater than b question mark a colon b. This a greater than b, if the condition is true, the value of a is displayed on the screen. The condition is false, the value of b is displayed. We can also write like this, that is a greater than b. The condition is true, it print a. The condition is false, it print b. So the next type of operator is size of operator. Size of data type or variable or constant. Size within a packet, we can give data type like integer, float, double, or variable or constant. In the example, integer a, it is a variable. In printf, size of a, it is a variable. Size of float, it is a type. Size of 45, it is a constant. A is a variable, it is an integer variable. So it displays the size of integer variable is 2. Size of float, float is a type. The float size is 4 bytes, so it displays 4. Size of 45, 45 is an integer value, so it occupies 2 bytes, so it displays 2. So size of operator is help to give the size of a particular data type or a variable or a constant. Next one is compound assignment operator. Compound assignment operator means that is plus equal to. It do two operations. That is plus equal to, minus equal to, star equal to. These are all the compound assignment operator. Example, a plus equal to 10. Plus equal to is a compound assignment operator. A plus equal to 10 means a equal to a plus 10. A minus equal to 10. This is a compound assignment operator. This is equivalent to a equal to a minus 10. A star equal to b. A equal to a star b. A slash equal to 10. A equal to a slash 10. If a and b and equal to b, a equal to a and b. A r equal to b. A equal to a r b. So this is a compound assignment operator. The variable declaration and assignments. Integer a, integer b. We can declare integer a. So a is integer, b is integer, but is a separate statement. To declare a variable a is a one statement. To declare b is a separate statement. We can also write a single statement, that is integer a comma b. So this is a comma operator. Integer a equal to 10, comma b equal to 10, c equal to 10. This is also valid one. We can write this statement like, that is integer a comma b comma c. First we declare the variable, then we assign. Here we declare and assigning, but here first we declare 3 variables. So it allocates 2 bytes for each variable. A has 2 bytes, B has 2 bytes, and C has 2 bytes. A equal to B equal to C equal to 10. The value is 10 is assigned to C, then that 10 is assigned to B, that 10 is assigned to A. And the 3 variable value is 10. But integer A equal to B equal to C equal to 10, this is a invalid one, because in this case, first these variable are allocate a memory. It is first declared. So A is an integer variable, so it allocate 2 bytes by operating system. B is integer, it allocate 2 bytes. In this case, A only integer variable, it allocate 2 bytes. B, C are unknown variable. It is an unknown one. In unknown one, we cannot able to assign the integer value. B, C does not have any memory. The compiler cannot able to find what is the type, and even compiler cannot able to know this is variable or not. So it is invalid. B, C variable is not declared. So it is an invalid statement. Then type conversion. If integer A equal to 10, float B equal to A slash 3. Integer A equal to 10, float B equal to A slash 3. A is integer, 3 is integer, but B is float variable. The size of B is 4 bytes. The memory allocated for B is 4 bytes. A is 2 byte, 3 is also occupied 2 bytes, because this is also integer, this is also integer. Integer, yield integer. So A value is 10, 10 by 3. The 10 is integer, 3 is integer, integer, yield integer. So the result is 3. That 3 is assigned to float location. So it stored as 3.0 only, not 3.33. Because integer, yield integer. That value assigned to float location. So it stored as 3.0 only. If we write like this, float B equal to A slash 3.0, A is integer, 3.0 is float. Integer float, yield float. But the result is assigned to float variable, 3.33 is stored to B. Suppose float and double, yield double. Just we can easily find out. If 2 operand is there, the first operand size and the second operand size, which one is high, that is the yielding result. Float, integer, yield float. Double float, yield double. Character integer, yield integer. Both are, that is both operand. If you both operands, one is integer, one is float main. So the first one is the size of first one is 2 byte. The size of second one is 4 byte. Which one is biggest? 4 is the biggest. So the result will be float. That is 4 bytes. Typecasting. We can convert the type of a particular operands. We need to type a specific operand or specific variable or a constant. We can easily convert it. For example, integer A equal to 10, B equal to 3, C. A has value 10, B has value 3, C equal to A slash B. A is 10, B is 3. 10 by 3, integer, yield integer. The C also integer, so 3 is stored to C. The value of C is 3, not 3.33. Suppose the D variable is float. If we declare as float D, the D variable is float. In this case, A slash B. Here we put within a param. This is float. This is typecasting. The value of A is 10. A is integer variable. So in this typecasting, that is within a param is float. It convert that 10 is float. Convert that 10. The value of 10 is converted into float. So after always A is integer. In this place only, that value 10 is converted into float. That is 10.0 divided by 3. 10.0 is a float, then 3 is a integer, float integer yield float. So 3.33. If the d is float, the value is 3.3 is assigned. If the d is integer, the 3 is assigned. But here just converted for the calculation only. But always a is integer. After the expression, the a value, a have only 10, not 10.3. A is integer variable. In this area only, it take the value 10, it converted it into float. So 10.0. 10.0 divided by 3, 3.33. If the d is float, if we declared as float, the 3.33 is assigned to d. Because C language is rich in operator. C language is rich in operator, rich in operators. So it is a fourth of C. Operators are fourth of C. So more operators is available in C languages compared than other languages. It has more operator. But we need to do the priority rule of operator, because the combination, if we create one equation, that is expression, by using different operator, which operator is first executed, then which operator is second executed. So this table provides the precedence of operator. So this is a higher priority. Then a parenthesis, it first executed, it is a higher priority, the second priority. This is the group 1. The first 4 is group 1. Then these are all group 2. These are all group 3, group 4, group 5. But this one is a higher priority group. The next one is a next priority, third priority. This is a last priority.